here's what I'm going to cover. I'm going to talk about, well, first of all, I'm going to remind everyone what the Agile Manifesto says. If those of you who haven't read it, it won't be a reminder, but hopefully most of you, if not all of you, have read that. And I'm going to kind of propose an extension to that, which is kind of a QA manifesto. A little bit of ego on my part there, but I'm also going to talk about my testing principles, so the things that I kind of try to live by in terms of how I think about testing. Then I'm going to go into the actual sort of DCQA strategy, just in some top-level kind of overview type of way. And then I'll tell you about where we are against that strategy right now, and talk about what we are planning to do next. Okay? So, first of all, how many of you have actually read the Agile Manifesto? Okay, a majority, I think. So I'm going to give some of you a reminder, and some of you the first time view. So it's a very kind of old document now, not quite, it's a lot younger than I am, but it's still quite old. So it's basically talking about individuals and interactions over process and tools, basically saying sort of people and their interactions, their collaboration over defined processes, defined tools. Working software over comprehensive documentation. In other words, you're much better off having software in your hand that works than having a set of documentation and no code. Customer collaboration, so collaborating with the customer, working with the customer to understand and kind of deliver a good solution over some sort of formal bureaucratic contract negotiations. And responding to change over following a plan, which is kind of the most popular tenet of Agile. Everyone says, right, throw out all the plans when we do Agile, we don't need that anymore, we just go crazy and change all over the place. But realistically, what this is saying is that there is definitely value in the things on the right, but we value the things on the left more. In other words, focus on one side of this, but still recognize you still need to do some of the stuff on the other side. And actually, for the first one, Agile defines a lot of process and a lot of tools, and a lot more rigor in some cases than some other development methodologies. So, how do I propose to extend that? Well, I prefer prevention over goalkeeping. And what do I mean by goalkeeping? Well, I kind of always have this, I'm a very visual person, so I have this kind of visual idea of QA folks being at the end of the line and trying to sort of literally sort of save the bugs from getting out to the customers. That's kind of what I mean by goalkeeping. So the prevention piece there is basically, make sure you avoid coding defects rather than trying to catch them at the very end. Risk-based over systematic coverage. So I'm talking about risk-based coverage, so cover the things that are basically risky rather than trying to cover everything. Good example here is, if you sort of have a web application product and you support, say, 7 different browser versions, don't try to test all 7 different browser versions for every single test you can think of, because that's systematic coverage, but it won't actually be valuable. You won't have risks in all of those browsers and across all of those areas of functionality. Focus on tester skill over test detail. So a lot of folks are probably in situations or environments where there's an insistence on writing very detailed, very prescribed, very step-by-step test cases. Anyone who works with me will know that I don't like those very much. I prefer to have brain-engaged testers who are thinking about what they're doing rather than following somebody else's typically prescribed set of steps. And automation over manual testing. This is a bit of care with this one, in the sense that I definitely prefer, if you can automate something, to automate it rather than test it manually. But there's a kind of semi-topical debate that's been going on for quite a while. James Back, Michael Bolton, and a few others are kind of trying to refine the definitions of testing and checking. Where checking is really something you can do programmatically. It's something you can say, if I take this action, then I can see this very defined, predictable result, like algorithmic, if you like. So there's a lot of automation you can do that'll help with those kind of things. And it's not actually very valuable to manually test that kind of stuff, typically, especially if you have to repeat it. So again, similar sort of style, like I'm saying that there is some value in the things on the right, but there's way more value in the things on the left. So focus on those. By the way, I should have said at the beginning, I'll take questions all the way through, but obviously I'll have some questions and hopefully some answers for you there. So, principles I kind of, I say I live by, but I try to instill them in other people too. So, fail fast, and I don't mean like, crash and burn. I mean, get an indication of a failure as fast and as cheaply as you can. For most testing, that's really the art of providing fast feedback. So, finding out that you've got a bug as quickly as you can, as cheaply as you can. Testing at the lowest layer. How many of you are familiar with the test automation pyramid? Show of hands. So folks that work with me, basically, because I keep drawing this for people. So what I'm really talking about here, and I will actually show you the test automation pyramid in a bit, is testing at that lowest layer, meaning testing at the lowest and cheapest layer of automation code that you can provide, which is typically the unit test. Big fan of test-driven development. So TDD is test-driven development. BDD is behavior-driven development, and we'll talk a bit about that later as well. They're both basically test-first methodologies. They're the idea that you come up with a test, and that test fails because you don't have the code that passes the test yet, and then you write the code that passes the test. You might spot some themes here, but risk-based testing for efficiency. So in other words, focus on the areas of your code or your product that are risky or likely to fail or are heavily used and therefore likely to be exposed to failure more than other parts. And focus on that. That gives you an efficient process where you sort of get a lot of value for a lower cost. Mentioned this before in the kind of manifesto, but the tester skill over domain knowledge. Tester skill and domain knowledge. Really, that's the idea that, again, back to those kind of prescribed test cases, that if you know your domain, if you know your product, and you're a skilled, capable tester, you don't really need someone to tell you step by step how to do these things, because you know how the product's meant to work, and you know what you're trying to do to expose issues with that. So you shouldn't need the prescription, you should just be able to do your work and do the best work you can do. Obviously, I drive for automation, and again, I've sort of mentioned the same thing, that repeated checking. So that's the kind of regression level stuff that we all know and love, but again, try to do that at the lowest layer, so combine those two. Learn from your mistakes, don't repeat them. That's an important one. How many of you see the same sort of bugs again and again and again? Go on, show of hands. Yeah, everybody does, right? What that really means is we're not really learning from the mistake that we made the first time so that we can actually take preventative measures and stop us from doing it again. So I'll talk a bit about that later too. So I try to think about a whole series of goals, and I do have a whole series of goals for my team every year. But there's really one goal. There's one goal any business wants, which is how do we deliver software at a high degree of quality and efficiently. And obviously the high degree of quality is completely subjective. If you're in medical instrumentation, or perhaps something that I used to do many, many years ago, more than I care to mention, I used to test flight deck software. So the quality levels there are, needless to say, very high. And most of us work in kind of application software that isn't really critical. It's critical to a business maybe, but it's not critical to someone's life. So you need to work that out for your business and what you need it to be. But the efficiency piece here is basically saying, how do I do that as fast as I can with the minimum cost? Companies want to make a profit, after all. So how do we approach achieving that goal? Well, the underlying focus here and the underlying theme of this whole presentation really, and kind of my ethos on QA is prevention. It's basically this, wonderful quote from Benjamin Franklin, and that's prevention is worth a pound of cure. So folks that work with me get bored of me quoting cheapest bug to fix is the one that doesn't get coded. Well, that's because all bugs in software are code. They are. Someone's written some code. They didn't generally write it maliciously to say, well, I'm going to write this code to see if the tester can find the bug that I've planted in here. Generally just make mistakes, misunderstandings, assumptions, etc., etc. What does it really mean about the cheapest bug to fix? Well, it's all relative, but that you can actually see really that graph very clearly, but there's quite a few you can find on the web about this, but it's the relative cost of when you find a bug to the cost of actually fixing it. So if you're talking about requirements, and if some of you are in waterfall environments, you'll know that that's typically a sort of paper-based process. But for most agile folks, that's a story. It might still be a piece of paper, and one of my previous companies used to use index cards on a corkboard as our stories. The point is, if you find an issue with that, so you're discussing the requirements, you're clarifying the requirements, you find an issue with that, it's pretty cheap to fix. On this kind of scale, it's meant to be like a cost of 1 or a multiplier of 1. And if you are doing design, and I'm a big fan of doing design via whiteboard rather than by expensive tool that you spend a lot of time and effort putting some lovely UML diagram or something together. Hopefully I don't offend anyone that's into UML. cheap whiteboard diagrams, quick, easy, and you can wipe them out when you make mistakes and update them, right? So it's not much of a big cost there either. And they really do facilitate finding some of these things. So that's a little bit more expensive, but not much. So then you find something in your code. Let's just say you've got some fantastic sort of unit tests coverage, and you check in your code and the unit tests run, and within seconds you find out, oh yeah, I've just broke something that used to work. So now you just change your code, or perhaps you need to update your unit tests, or maybe add some new unit tests to help catch things like that again. So a little bit more cost, but still not much. You're probably in the sort of 5 times multiple at this point. Then if you get on to the point where you hand it off into sort of, whether it's a centralized QA department or whether it's just the guy sat next to you and they do some testing, well, if they find an issue, now there's a bit more communication overhead, because typically we use bug tracking systems and they've got to raise it and kind of talk to you about it, and then the developer's got to figure out how to reproduce that, and sometimes we're not very good at telling them basically how to reproduce it. And then you've got to change the code, obviously, and commit that back in and go back through the test process and whatever got you to the testing phase at that point anyway. So the multiple there is more likely to be around a 10, sort of, and again, relative to the requirements phase. So then the worst case here is if the customer finds it, if you find it in production. Because now you typically got a large proportion of your organization involved, and this is not even talking to the impact of the customer, the fact the customer may actually walk away from you, not give you that kind of license renewal that you're looking for, or buy that next feature from you, or whatever it is. But there's a huge kind of set of things that you need to do. So that's the cost of defects, and that's why you want to catch them as early as you can, and if you can at all, prevent them. So how do you do it? Well, first of all, it's like a boiling the ocean problem, which is what that graphic's meant to be, by the way. So you all know that you can't exhaustively test, right? You can't test everything, you can't test every permutation, you can't test every system, every configuration of your system. You just can't. There aren't enough people, there isn't enough time, and it just isn't worth doing. So one of the best ways of kind of at the surface level thinking about this is to apply some critical thinking and ask intelligent questions. So how many of you have been in that situation where you've been talking about some work that you're doing, or maybe just in a sort of a general discussion about some work that you're doing, and there's some developers there, and you sort of say, well, what happens if that bit over there doesn't give me what I want, or the database is down, or something like that, and you kind of watch their face and you realize they haven't thought of that. That's a really silly example of critical thinking, but the point is that we may, or generally, we do think differently. So when I'm recruiting folks for QA roles, I'm looking for folks who think differently and think critically, basically. So what do we do? Well, first of all, we do that sort of wonderful phrase that everyone talks about, make quality a team deliverable, right? It's easy to say, but is it actually easy to do? And the answer is no. But we try, like everyone we try. So we try to share the responsibility in the sense of everybody needs to play their part in delivering quality code, and I'll get a bit more into detail of that too. The other thing we do, and this is a kind of a key difference for prevention, is we focus much more on white box and grey box. So I'm presuming everybody knows what black box, grey box and white box are. There's some help there. The black box is really that sort of what I call the traditional QA model, where you generally are somewhat separate from the folks that are writing the code, and you understand how the customer's going to use your code, you understand the business domain, and you try to test from that perspective. So a good example of this might be a web application, web UI, with some sort of data entry form field. And you think about this and say it's, I don't know, so it's meant to be enter some name between 3 and 10 characters. And as black box testers, we're going to think about all the boundaries and all the equivalence classes, and we're going to test something out of that, right? So that's good, and we'll spend some time doing that, and we may or may not find some issues. But by the time it's actually got to us to actually do that kind of level of testing, it's gone through an awful lot of process, and a lot of time has been spent getting it to us. So is that really efficient? We find a bug there, we're at that sort of test stage on that previous graph, so we're at a 10 times multiple of the cost, chances are the developers have moved on and started work on something completely different if we find a bug at this point. So with a bit of grey box help, we could perhaps know that the UI is talking to some back-end service, and that back-end service may or may not have some validation on it, may or may not work at this level, and may or may not have been developed before the UI was developed. Therefore, we could have tested the back-end service before we actually got to build a UI on top of it and found out whether it was going to fail on validation on some of these things. But even better than that is if you actually have access to the code and the coder or coders, and you can work with them and kind of know the intricacies of how they're actually putting together that code and a tiny little bit of code units that sort of might do some of that validation, you can test at that level. Or even better, you can get them to test at that level with you telling them what they need to test. And if you do that, it's generally really cheap and fast. Again, a bit more on that later. So, who does this work? So here's our kind of roles. So first of all, we have kind of two QA roles. So we have a kind of what I call a traditional black box customer and biz domain focused tester in a quality assurance engineer role. And I kind of add grey box to that because I really do encourage folks to get some level of understanding of how the code is structured and how it's kind of architected in order to help them design good tests. And then we have a software engineering test, which I shamelessly stole that phrase or that name, terminology if you like, from Google. So Microsoft have a software developer test, an SDET. I find it harder to say, so I called it an SET, software engineering test. And as I've kind of already mentioned, these are folks that are white box focused, right? So they understand how to code, they know how to code, they know how to read code, and better than that, they have a negative mindset, critical thinking mindset. So instead of the traditional, and I know there's a few developers in the room, the traditional sort of level flight thinking of a developer. I mean, a developer writes code to say, well, I'm writing this code to solve a problem, so I'm positively thinking, right? I'm not deliberately writing code to not solve the problem, I'm writing code to solve the problem. So you're positively focused. If someone comes at you and says, yeah, but what if, right? So between the two of them, they can get some good stuff going, and they can kind of share the load of like automating tests at all of those layers that we're going to talk about. So that's the kind of QA roles, and we also have quite a strong focus here on usability and workflow. Right? We want to build a product that our customers, well, they basically find it intuitive. They want to use it. It makes sense to them. It helps them solve their problem. They don't have to read a 3,000-page manual to figure out how to log in. And we have product managers, and there are kind of customer proxies. Right? There are folks that give us our requirements, but also they're the folks that act as the customer accepting the story at the end of the sprint or whenever it's done. And then of course we have developers, we have lots of developers, and they're responsible for coding solutions, unit tests, integration tests, sometimes workflow and UI tests. And as I kind of mentioned earlier, making sort of quality a team effort, obviously there's some indication of whether they're doing some quality type activities there. But the PMs are also doing that in the sense of requirements clarification, and acceptance. And the UX folks are kind of working with us to make sure that we have a product that people are going to want to use and is a quality from that point of view. So it really genuinely is a team effort.
Question?
Yeah.
It doesn't say who does the risk analysis on this page, is it?
Yeah, deliberately, I guess. Everybody. That's going to be my answer to most of these things. So it's a good question. So if anyone didn't hear what it was who does the risk analysis? And the answer is everybody. And the reason for that is you want the collaboration, you want everybody's different perspectives into this. And like I said, we will kind of get into this in a bit more detail, in fact, on the next slide. But I do want to mention sort of what's my role in this, and what's Duncan's role in this. And where is Duncan? I can't see him. There he is. So Duncan's a QA manager at VC. And so we kind of have this role of facilitating this, of helping people be better testers and kind of do the best job they can, be the best testers they can, if you like, rather than a focus on, what are you doing right now, and shouldn't you be doing this other thing that was higher priority, or any of those kind of things, right? So we do an amount of setting process and everything else, but most of what we're trying to do is help people be better. And it's not just testers. So, I got two. Hang on a sec. Someone asked me a question? Okay.
No, I just wanted to tell you that.
Oh, sorry.
Speaking about these roles, what is the rough ratio between the number of developers
traditional QAs and software engineers of test, what ratio do you think is appropriate?
So I always get this question. So it depends. It's a good. Sorry, the question was, what is our ratio between developers and testers, and in particular developers and SETs versus developers and QAs, and what is the right ratio? And the answer to the right ratio is it depends.
What about your company? Give us an example.
Sure, I'm going to. So typically we have 3 or 4 to 1 in terms of developers to QA. Now, in terms of developers to SET versus QAE, that really does depend. So for example, if you've got a team that is really good at writing kind of white box level tests of unit tests, integration tests, they probably don't need much help that way. So they probably don't need an SET, but they do need some help from a QA, someone who understands the business and the customer focus point of view, and they'll add value at that point. So that's why it depends. So it's kind of based on the team skills, the team's capabilities, and kind of getting that right mix. So there isn't a formula. I can't give you an answer that you can all go away and say, hey, we just apply this and it'll work. It won't. People are people. We're all individual, and we all have different levels of skill, experience, background, everything. So you have to work with what you have. Does that answer your question? Sort of?
It depends.
Of course. It's going to be my answer to a lot of things. So, talked about it a bit. Behavior-driven development. So something we're doing here, it's quite a popular methodology. And it's not just a development methodology, it's certainly not just a test methodology, but it really is focused on communication. And it really is about making sure you all know what it is you're trying to do and what done looks like. Like, how are you going to accept what you do as to say, this is good enough, or this is what the customer wanted, or this will work exactly the way we want it to. So it's typically thought of as the 3 amigos, and sometimes 4, because we have UX folks as well. So he's the usability folks. So if we're doing something with workflow or doing something with the UI, we typically have 4 amigos. But you need at least the customer representative, which in our case is a PM, product manager, developer, a QA. And you get in a conversation and you make sure that you're all using the same common language. You know, that when you say something, everyone knows what you mean by that something, because we all use interchangeable terminology. And we as a company are pretty bad at that. And you want to come out of that with shared understanding. And what that really means is that you're all actually understanding the same thing. There's a common problem that I used to find in kind of more waterfall-like environments, which I used to call fork and ambush, where you would quite literally sort of, someone would deliver requirements and then kind of run away. You know, give you this big document and then they kind of leave. And then the QAs would sort of take that document and go off into their own corner and kind of write their own test for this. And based on their interpretation of these requirements, there wasn't anyone around to ask. And devs would go off into their corner and they'd write code that was going to solve those requirements or deliver, functionality or features that would meet those requirements. And then at some point later, those two would come back together again, and I used to call that an ambush, because typically the testers would be saying, okay, so I think it should work like this, and it doesn't. My test is failing. And the devs say, well, I didn't design it like that, because that's not the way I understood it was meant to work. It was meant to work like this. Worst case scenario is the PM comes along after all these, warring factions, and the PM says, well, you're both wrong. It's not what I wanted at all. And you have to go back and start again. So BDD uses a kind of a prescribed language, if you like, a structure, and it's called gherkin. It's a bit of geek humor. I won't get into it, but it's basically given when then. So the idea here is that you're stating your tests in this format. So you're saying, given some precondition or some data or some setup or some environment or whatever it is, when I take an action, then I'm going to see a result. So it kind of sounds a little bit like one of those lovely prescribed tests, but it's a little bit, there's some subtleties in this. And if you practice it, if you get into doing BDD, you'll find it actually helps a lot in terms of clarifying what it is you're doing and what you really expect to happen in terms of your behavior, and how you can then accept the story based on it. So we start with BDD, and then we do this. So you asked earlier, so typically we would expect all those that are working on a feature or a story to get involved in the BDD, and then also get involved in applying some critical thinking and some risk analysis. So really the critical thinking, I kind of described it earlier, of like asking all those kind of interesting questions and kind of thinking about what can go wrong, where it can go wrong, why it can go wrong, and then sort of taking that up a level and saying, okay, so what's the likelihood of that going wrong? What's the probability of that going wrong? And if it did go wrong, what's the consequence? And through that, you can figure out what the kind of priority is. So it's a kind of a risk matrix, and there's obviously variants on a theme to this. There's different types, but there's a simple one up here. So having figured out the risk of things, then you can actually prioritize what you need to focus your time on. And again, it's back to that efficiency piece. We know we can't test everything, so we're actually trying to figure out what's the smart things to test. So once you've figured out those smart things to test, the next question you've got to ask yourself is, well, where do I get the coverage for that? Where should I test that? So I kind of mentioned this earlier. This is something I learned quite a long time ago. There's a guy called Mike Cohn, and Mountain Goat Software, if you want to look him up. So he drew this very simple triangle a long time ago, and there's, again, lots of variants on the theme here. But in essence, you've got these kind of three sort of common tiers of unit tests at the bottom, and the idea is the breadth of the triangle here is that's the number of tests. So the highest number of tests, the largest count of tests, if you like, is at the unit test layer. And you're building a pyramid because it has to be a strong foundation, right? So then the next layer up is integration tests. And the reasoning here is that you, having got good unit tests, you then know what you're covering at the kind of individual code unit level. You can then build a slightly smaller set because you don't need to cover as much at the integration layer. So think of integration as, well, anything really. I mean, it could be two pieces of code talking to each other, like passing data from one to another, or passing a setting that another one picks up. Or it could be a REST API or a Windows service. So it could be at the code-to-code level or system component level. It could even be you talking to a DB, for example. And then at the top, you typically have your kind of UI-based or sometimes system tests. And generally speaking, most companies try to do that first. Quite often you get in a situation where you've got all these kind of big sort of test case management system with tons and tons of these really heavily prescribed test cases in them. And then they go out and buy a really expensive tool, I won't name any names, and then they try to automate all those. And that's their automation plan or strategy. And it's incredibly expensive and incredibly fragile. Next change you make to the UI will typically break that unless you develop them very well. And most people don't. So you want to make them the kind of smallest, narrowest point on your pyramid. You want to try and have the minimum number of tests. I kind of gave you that example earlier, a really stupid example, but it hopefully illustrates the point. If you had a web app and you've got this kind of form field that you're trying to sort of make sure that someone's entering, alphanumeric characters between 3 and 10. No more than 10, no less than 3. If you try and test all that from the UI and you do it with an automated UI test, you can definitely do it. And it's actually not that expensive to do at that simple level. But as soon as someone changes any subtle thing about that, it will get expensive and it will break. But the real trick here is you could have done most of that permutation testing at the unit test level, both in JavaScript in the UI if there is client-side validation, and obviously in the server side, whether it's API layer, whether it's Windows services, whatever it is that you're passing it back to, you can do it there too. And you could have done that in these lower levels, and then knowing that you've got that done, your UI test could simply be just enter any number of characters that are in the right range between 3 and 10, because you don't need to validate anything at that point. Unless, of course, you've got a UI error message that you want to validate and make sure that shows up correctly. Again, you can unit test that too. So this was, for those of you that were at the last VanQ, the AirInfo, the Boeing folks actually talked about this too as part of their kind of move to TDD. And the cloud at the top is cloud because it's kind of variable in size, right? You do some manual testing. You can't get away from doing manual testing. You shouldn't try to get away from doing some manual testing. You always need eyes, real human eyes and real human brains applied to the testing process. That's why we don't just have SETs here, we have QAs as well. So what do you do with all this? Once you've automated all these layers, well, how many of you work with continuous integration systems? Again, all the folks in this building plus a few more. Okay, not that many of you. So this is a really simplified view of the world, and it's deliberately sequential, which in reality we don't typically do. We do a lot of things in parallel. But let's assume you've got compiled code of some kind. So you've got a build process that compiles that code. The next thing that we do is we unit test that code. So back to the failing fast principle of getting fast feedback. Here's the point where you've got that massive test at the base of your pyramid that are incredibly fast to run and really cheap to run, and they're going to give you feedback straight away. So moments after you've checked your code in, your change of code, you're going to get some feedback. And it becomes a safety net, it really does. Developers, when they get used to this, will never sort of break the habit. Once they've had a safety net, they don't want to get on that tightrope again without one. The next level on is typically for us an integration test. So that's, kind of typically some elements of code are being integrated with some other elements of code, or some system components are being integrated with some other system components, and we run tests at that next level of the pyramid against, whatever that integration is. Again, fast feedback is the fastest you can get at this point in time. So if your unit tests haven't discovered anything, but suddenly your integration test does, because it's talking about how two different system components talk to each other, you get the feedback then. We quite often run a smoke test, and I won't go into the history of smoke testing either, but I'm old enough to know the real reason why it's called smoke test. But a smoke test is really now sort of, we typically use it to say, okay, critical path of what the customer might do with our product works. In other words, our product fundamentally does what it's meant to do at this point. So it's a simple set of tests, but it's generally confirmation focused. You don't look for bugs at this point, you are just trying to make sure your product actually does what it's meant to do. Not in all ways, in all permutations, just level flight, critical path. And the reason you're doing that is because you're trying to make an assessment. Each one of these is kind of like a stage gate, if you like. You're trying to make an assessment whether it's worth doing the next stage of this, whether it's worth promoting this code that you've just built and you've just tested to this level into the next stage, because each progressive stage is generally a little bit more costly and a little bit slower in the feedback. So I kind of threw in the next one kind of deliberately because it's very unusual in CR environments, but we've actually started getting this going here. Sanjay's around somewhere. There he is. So Sanjay's running, or one of the teams he's running, is actually adding performance tests into our CI pipelines. And what that means is we're getting very regular feedback on how our code is actually performing in a kind of customer-like way. So simulating large amounts of customers using our product, which is really cool. And the very last stage here is the acceptance test. And this is quite often a combination of automated tests. So the tests at the top of that pyramid are going to be a kind of UI tests that really were written at the BDD stage. They were kind of designed at the point when you've got everyone in the room saying, okay, what's this story about? Why are we doing it? Who are we doing it for? We're coming up with this nice agreed set of given when then statements that say that's how we're going to define done for this story. If it passes those tests, it's acceptable. So where we can, we automate those. So you could run them at this stage, and quite literally, if everything's good, we should be in a position to ship that code. But 9 times out of 10, we're not quite that good yet. So we run some of those tests automatically, but we also have manual acceptance. So we typically get the PMs back and say, okay, this is what we built. It looks like this. It works like this. What do you think? It's good enough? That's basically what it looks like. So the later stages of this, sorry, Ashman?
So are you saying that apart from acceptance testing, everything else there is automated?
Yes, sorry, yes. Yes. That's a very key point, actually, and I completely missed it. So it's really feeding from the, sorry, the question was, is everything automated? And yes, it's feeding from this. So these are all automated tests apart from the fluffy cloud at the top. And you are feeding them into this system so that you have this progressive stage gate system that's saying, okay, I build, I can compile my code. It's always test number 1, right? And if that works, then we promote it into the unit test and we run the unit test and get feedback from them. And if that works, then we promote it into the integration test. So we have build monitors around the office. If ever a build goes red, basically someone notices, and sometimes we have flashing lights that tell us it's red as well. We have more than one build system, by the way. So someone gets on that, and basically we have a policy of not allowing check-ins on a red build. So if a build's red, it's broken. If it fails any of these tests, no one else can check code in until we fix it. We don't always honour that. We are humans. We actually, after these kind of stages, because our like most people's code and application code, any code that's been around for a long time is a little bit more complex than simple diagrams like this kind of can show. So we actually have further kind of integration stages and system testing stages as well. But I just wanted to give you a taste and a simple explanation. So I had a fluffy cloud at the top of my pyramid saying we'll do some manual testing. Our aim, our focus, my strategy is that this is exploratory in nature. That this is really the point where you're doing the really brain engaged, as I call it, testing. This is not following some script. This is, you are thinking deeply and constantly about what you're testing and what you're looking for, looking at what you actually got. So do your test design, think about what you want to prove or disprove, execute whatever it is you come up with, analyze the results, and then learn from it. So if your result tells you something unexpected, maybe it takes you down a path that says, oh, that was interesting, maybe if I try this, I'll get a different answer. And you just keep going around that loop, either until you've kind of time boxed this process and you kind of say, I'm done, or you basically run out of ideas. So again, we're not that great at this yet, and we'll get into where we are right now, but we're still currently in the phase of kind of doing some manual testing that is focused on look and feel, it's focused on usability and workflow, so we still have some of that. So I talked earlier about not repeating your mistakes. One thing most agile folks do is they have retrospectives, and we do these in every sprint. This is kind of one of the more popular retrospective styles here. It's not actually my favourite at all, but it's a nice graphic. It's a quadrant idea. I guess I should ask, how many of you do retrospectives? Frequently? Oh, actually, a lot of folks. That's good. Do you learn things from them? A few nods. Do you change things as a result of what you learn in your respect? Oh, a few shakes of heads. That's not good. Okay. So another thing we do is root cause analysis, RCAs. Again, this is part of strategy, and again, it's not something we're doing perfectly well right now, but we use the 5 whys method, which is kind of a popular method that was introduced in sort of the Toyota folks and the lean kind of movement. And it really is that idea that if any of you have got kids and the kid kind of asks you why, and why, and why, and why, and after a while you get so bored it just is. But the idea is that you get through enough kind of questions about why, and you actually get to the real root cause. Now, most people do this because they want to know the root cause of, say, a bug, right? Like what actually caused the bug. Well, I do this to say, why didn't we find it? So I tend to do root cause analysis on why did this issue escape our attention? Why did it get all the way through our CI systems, all the way through our manual focus on this stuff, our risk analysis, our critical thinking, our exploratory testing, everything, and escape? Keep asking why, and if someone says, well, there wasn't time to test that, well, why wasn't there time to test that? What were we spending our time doing, etc., etc. Get the idea. So, where are we against this strategy? Where are we today? Well, currently, we have 1 week sprints, which quite a lot of people find quite scary. It is fast moving, but it definitely keeps you on your toes. And we typically deliver fixes weekly, or at least we have the capability of delivering fixes weekly. We don't always choose to do it. And we typically deliver features monthly. So what does that really mean? Well, we're starting to move more towards the kind of continuous delivery model, and we're starting to sort of get better at sort of having things behind a feature toggle so that we can actually keep delivering code but not necessarily make it available, not necessarily make the feature available, which is slightly different to the more sort of I don't know, longer term view of plan to deliver something on month end kind of idea. So we deliver that. Sort of. We actually mix Agile, Scrum and Kanban together in our process.
And is it possible in your process one sprint to change some requirements?
Mm-hmm. Frequently happens.
And how people how they handle developers, how they react?
Generally pretty good. So the question is about how do we handle change in sprint or in like a 1 week sort of flow. One of the things that everyone has to kind of get used to about Agile is the point of Agile, if you like, is recognizing that change is inevitable. And that when you do things, you'll learn, you'll learn things you didn't know when you started thinking about the problem you're trying to solve. So you think it might be easy to solve this problem, or you get a story and someone says, oh, I know how to code that. They start trying to code it, and it's like, no, actually, that isn't so easy. Or we'll start thinking about how to test it, and we think, that's easy to test, and then we'll get into it and go, actually, no, it's not. And so we learn things all the time, and it's kind of back to that idea of if your process is cheap and lightweight, then actually change is also fairly cheap and lightweight. Right? So the idea that if you're just doing whiteboard, design, and that's when you surface that kind of problem, it's cheap to wipe the whiteboard out and start again, right? But sometimes, yeah, you've kind of committed some code and you're kind of getting to that point. You have to redesign. So it is somewhat inevitable, but the whole point of Agile and the point of the sprint or the kind of the short cycle is actually that's the biggest waste you can have, right? So the idea is that we have 1 week sprints. So the worst that can happen to us is we've wasted a week. If we get to the end of that week and whatever it is we delivered, the PM says that wasn't what I wanted. Okay, we wasted a week. I gave an example earlier of fork and ambush, and I've told a few people this, and I won't tell you the name of the company. But many years ago, I worked for a company, and we actually had an 18-month epic fail, where you had basically a massive waterfall process, like 3 months to gather your requirements, 6 months to design, and then another, sort of X amount of months of testing and going through all sorts of layers of iteration backwards and forwards with bug fixes and everything else. 18 months later, we kind of said, well, we're done, we got this thing now, and the PM goes, no, it's not what I wanted. So yeah, very expensive failure. Don't want to do that again. So that's kind of the point of Agile, right? Is that you have short cycles, that's the scope of change is minimal, and you don't risk wasting that much.
Question.
Yeah.
When you say you finish bug fixes in a week, is that bugs found during that sprint, or is that bugs found previously which were scheduled to be done as a feature or an item? Okay,
so the question is, when I say we deliver, sorry, you actually said we fix bugs in a week. I actually said deliver.
Okay.
So there's a difference. So your delivery schedule can be completely asynchronous to your fix schedule. So I could have fixed that a month ago, but only chose to deliver it this week. Or it could have been the thing I fixed yesterday and I'm delivering it this week. So I wouldn't tie those two together is the point. So if you want to go into a continuous delivery model, you want to get to the point where you're actually capable of delivering frequently. And then you want to develop the capability of choosing what you deliver and controlling it. I mentioned the feature flag idea, which is the idea that you can deliver code that's behind something that you have control over. So no one gets to see that something. You're delivering the code, it's physically out there, it's in production. But no one's executing it or exercising it until you flip that toggle. So yeah, we're delivering weekly. It doesn't necessarily mean it's the fix we did yesterday. It might be the fix we did last week. Or it might be a combination. In fact, normally it's a combination, right? You get the classic sort of, okay, the delivery schedule for tomorrow, can we just get this last bug fix in? Well, no, because we need time to test it. Oh, sorry. Yeah.
I think by the question I have, you answered it. If you have continuous delivery, why bug fixes happen at a certain time? Shouldn't it just kind of all the time?
So yeah, so we're not doing continuous delivery yet, but we are aiming towards it. Yeah, so this is where we are today. This is kind of our current state, if you like, but we are trying to move towards CD.
The question is, with 1 week sprints, how do you find retrospects, demos, and planning? How much time do you spend for all of those when your sprints are only 1 week, which is 5 days?
The simple answer to that is we don't spend much time doing those things. So I kind of mentioned earlier that we kind of mix Agile, Kanban, and Scrum together. Yeah, we kind of smorgasbord that stuff, and it's not great. But essentially, we will treat most things like Kanban in the sense of we don't expect to finish a story at the end of a week. So we don't do a big sprint planning session, and then expect at the end of the sprint to do a big demo session of all the things we delivered in the sprint. And that messes with most people's heads, but the sprint is just there for rhythm. It's just there to say, we're going through a cycle every week where we have some checks and balances. That's all it is. It's not the traditional sprint. You have some goals, but they're more Kanban based. They're more like, once I've done this thing, then I pull this next highest priority thing. So there isn't really the kind of sprint plan that says, in this sprint I intend to finish these things. Not really strongly, not in the way that most people think of that. We will have some idea, more often than not, it's the kind of bug fixes that we'll target at a sprint to say, we need that at the end of the week. Back to the other question, right? When do we deliver those bug fixes? But we won't tie a story to a sprint per se.
How often you have releases to production?
Can be every week. Some of our products deliver every week. And again, it doesn't mean that they're delivering finished code. They can deliver code behind a flag. So they're checking in codes, going through all the test systems and everything else, but it's not actually being kind of exposed to anybody in the true sense of you can use that. Okay, so obviously there's a wealth of metrics you can really focus on and everything else, and I just wanted to keep it simple for today, and obviously these are, to me, some of the most important things to focus on. And honestly, I spend most of my time focusing on customer defects. We as testers can raise hundreds and hundreds of defects, and some of those, we have to be honest, no one cares about. I don't really care about fixing that weird edge case where you roll your head on the keyboard and something strange happens. It's a fun test, but... So, I care about the things that bother the customer enough that they're going to pick up a phone or send us an email and say, I don't like this is broken, it doesn't help me, it doesn't solve my problem, or it does this weird thing whenever I try and do this. So, one of the things I look for is, are we keeping up with the incoming? So if we can keep up with, the customers calling us and saying, I've got this problem, if we can keep fixing those and, keep up with that incoming rate, or better, exceed that incoming rate, because most of us have a bug backlog, then we're doing all right. And we are currently doing all right. As if Jeevan cringes at me over here. I'm talking about our next generation product, not our legacy product, okay? Being careful about that. So the other one to focus on is what's that time between when someone's reported an issue, customer again in this case, and we've accepted the fix for it. How quickly are we turning around a resolution? So the first one's talking about, are we keeping up with the rate? It's like a flow-based thing, and this is more of a, so how quickly are we, customers unhappy on day one, they're calling us and telling us they've got an issue, and how many days is it until we actually make them happy again by saying we solved it for you? And obviously, with a weekly fix delivery, the best we can hope for is going to be a week. When you get to continuous delivery, obviously the best you can hope for is minutes, an hour, however quickly your pipeline can run. So right now we're in the amber state. We can basically, do a pretty good job of this, and we have this kind of unofficial SLA, which is the next one. So we have a couple of high priority bugs that we've triaged and said these are, highly impacting issues that are older than 30 days, which is kind of a month that we set on the highs. We have criticals and nows above that. So critical needs to be fixed within a week, and a now is like a stop everything and fix it now. So we have this unofficial SLA, and it's a service level agreement, and it's unofficial because we're not really at a maturity point where we want to commit to this. But this is the idea that you work with your support department and say, okay, so we will commit to the idea that we will fix an now bug within a day, we'll fix a critical within a week, we'll fix a high within 30 days, and we'll fix a medium within, say, 90 days or whatever. So again, we're not doing too bad, but we have a couple of highs that have been open longer than 30 days, like I mentioned above, and we also have a few less than 10, but a few mediums that are kind of not making that either. The last one's an interesting one, so I don't know how many of you have heard of defect detection ratio or defect detection percentage. Anybody? Folks that work with me and someone else? Okay. So really the idea behind this is what is the ratio to where you're finding these defects? So this is internal versus external, or the amount of issues raised by your customers versus the amount of issues you're finding. It's kind of back to that goalkeeping kind of thing of like, are we actually stopping the bugs getting out the door? But it is a useful health metric for like how well are we actually doing that kind of, not allowing things to escape our attention kind of thing.
Are you doing that based on the severity?
Yes, you can. I mean, obviously this, I'm deliberately making it simple, but yes. Yeah. I mean, back to the like, which bugs do we care about, right? If the customer's actually calling you about, this is like 1 pixel off, or that font's a bit weird, if they call you with stuff like that, you're doing a fantastic job, right? So yeah, I mean, if you sort of see a DDP or a DDR that's kind of looking at low issues and that's where you've got a problem, then pat yourself on the back. You're doing a great job. But yeah, I mean, generally speaking, it's not that. I kind of give us a green light on this, and even though it's 93%, but I think honestly, if less than 10% of your bug rate is coming from your customers or found externally, then I think you're not doing bad. I have worked at a company, been responsible for this, I guess, where we had a much better ratio. But it took us a long time to get there. So what about the stories? So again, some simple metrics here, but I keep talking about the word efficiency, but testing lead times. So this is the time, when we go into that state of now it's in testing. How long do we spend there? How long do we stay there? How much time are we spending testing? And lead times is a bit misleading, if that's not an overuse of the word, in the sense that we don't always kind of add value in this stage. Right? Sometimes we're in the testing phase, we find a bug and we leave it in the testing state, we go back to the developer and say, hey, can you fix this? So it's kind of a non-value add, if you're familiar with lean, there's a non-value add kind of activity going on there, or a wait state happening in there. So we're trying to get better at that, but we're not great at the moment. And the BDD, and another way of describing BDD, and perhaps a better way of describing BDD, is specification by example. The examples being the test that you're actually writing and say, this is how the code should work. If it does this, then we're going to accept it. So we're fairly new still to kind of practicing BDD, so we still have some improvement to make there. Those of you that have been around Vancouver a long time, I think it was last year I presented on coverage outlines. Again, I don't like really heavily prescribed test cases, so we use very lightweight spreadsheets, and they're not maybe the spreadsheets that you're used to. You'd have to sort of see the presentation or see my blog to see what I'm talking about. But we need some improvement there too. And all this is me being honest, right? So we are still practicing BDD. Still getting better at this. I've been running workshops with all the folks in the company, and we've kind of got some ongoing coaching and mentoring going on to sort of get better at this. And it does take practice, it really does, and it's not just the QAs, everybody needs the practice, everybody on the team. But we're already starting to see some benefits from that. And we're trying to develop our critical thinking and risk analysis skills. So I use a lot of heuristics, like fallible guides for helping people think about test design and kind of risk analysis. How do you shape that what if question? How do you think about all the things that you might need to consider as part of this? I draw on a lot of folks that are way better and smarter than I am, so I kind of follow a lot of thought leaders in testing. So I get a lot of the heuristics from folks like James Bannock, Elizabeth Hendrickson, and folks like that. Jonathan Cole, Michael Bolton. Not the same. We use whiteboards a lot. I can't emphasize this enough. Like even if you don't know how a system really looks, or you can't model it perfectly, if you go and start drawing something on a whiteboard in front of the developer or the architect or the PM even sometimes, they will probably point out where you're going wrong and help you get a clear picture and a clear idea of what's really going on. And having a diagram really helps facilitate good conversation. Make sure you're talking about the same thing, you understand the same thing, and that you can sort of point to, oh, what's going to happen if this doesn't work the way we expect. And obviously, collaboration. BDD is all about collaboration. It's all about sort of forcing, if you like, 3 amigos or 4 amigos together to talk about what it is we're doing and why we're doing it, and who we're doing it for, and coming out of that with these kind of examples that are specifying how the behaviour should be. And Agile really talks about collaboration, right? We physically sort of arrange our space so that all the teams, the devs and the QA sit together, so they just literally turn around and go, hey, I've got an idea, or hey, I've got a question. So we facilitate collaboration. And I kind of mentioned earlier that a lot of companies start off with doing this the wrong way around. Well, when I came here, we had this lovely sort of trapezoidal shape. We didn't have a pyramid, and we still don't have a pyramid. So we had all the QAs that were automating their existing tests were doing the kind of black box UI-based automation type approach. And we actually had some pretty good practices in dev where they were actually adding a lot of unit tests. Maybe I'll give a separate talk sometime about how fallible some thinking around unit tests could be, but essentially we had some amount of reasonable coverage, or at least a reasonable number of tests at both the unit level and the UI level, and we had very little in the integration level. So that's the kind of shape change or morphing or whatever that we're trying to achieve right now, and we are investing in that to do that. And really that is talking about improving our coverage. So I mentioned as well that we try to RCA. Now right now we're kind of doing the root cause analysis on the sort of most critical customer issues, because we just don't have the time, or I don't have the time typically, to facilitate those conversations for all escaped issues. But hopefully we'll get better at that, and there's a lot of folks on the teams that are helping me out with that too. lot of the senior QAs are kind of taking on the RCA challenge. So what's next? Well, kind of the hints have been in the slides really, but we really want to reduce our lead times, and this is kind of around this piece of getting towards continuous delivery of being able to say, checking code at time A and time B when it's in the customer's hands is moments away rather than days away. And there's a lot of automation focus in getting to that point. We want to continue to practice our BDD. We want to get better at specifying with examples. And I'll continue to push for TDD. It's really hard to do, but it's very valuable. Writing a failing test before you write any code that passes the test is incredibly valuable. And we'll continue reshaping our automation, like get that trapezoid shape into more of a pyramid shape. And yeah, as I've said, continue to drive to continuous delivery. So that's our future, and it's quite bright. Any more questions?
Yeah, question. It's well known that testing is not about tools, but about people. So they provide the insight and report. So how do you motivate your team members? Because I haven't seen anything related to that in your plan for the future.
Maybe I should ask one of my team members how I motivate them. Would you like one of them to answer that question?
Probably.
Volunteers? Anybody?
What was the question?
Oh, sorry. The question was how do I motivate the QA folks to do a good job? Yeah.
Stuart doesn't motivate me to do a good job. I motivate me to do a good job.
Perfect answer. For those of you who didn't hear that, I don't do the motivation. Jay does the motivation. He motivates himself. And that's actually part of it. I mean, you've got to want to be the best you can be. Right? I'm going to encourage that. I'm going to facilitate that. I'm going to support you in that. But I'm not going to make you do that. I'm not going to stand behind you with a whip. In fact, I'm not that type of director or manager at all. Right? I'm not a task-based someone who's going to say, you need to be doing this. No, no, no.
No, I was thinking about creating a specific environment, encourage people to do self-education, do some reward programs to choose the best team member, or give them the example how to do DHO.
Yeah,
Something like this.
So we definitely give examples. We talk, like I talked earlier about coaching and mentoring, right? So we do that a lot. We do that for each other, and we do that, like I do that as well. So on the teams, we expect people to help each other out and teach people things that they don't already know. We also expect people to ask about things they don't know to learn better. Simple example, I just sort of mentioned, draw something on a whiteboard. Even if you know it's wrong, you'll get something going, and you'll get someone to correct you, and then you'll learn. So you're creating the environment for yourself to a certain extent, but we facilitate that. I have a library of books. I encourage people to self-learn. I ask challenging questions all the time. In fact, most people call one-to-ones of me interviews because I test people all the time. What else? We make sure that, say, any of our CTs get their code reviewed by senior developers on the team, so that the senior developers can give them feedback on better ways in which to code those things. Sorry, Vanessa,
yes.
Want to add something?
You also answer questions with another question to make us think further instead of giving us the answer.
Yeah, that's a pretty good point. I'm quite annoying. So if you didn't hear that, basically, whenever someone asks me a question, I generally ask them a question back. I don't just answer their question. So I encourage people to think about things. I don't want to just be the person like, someone asked me earlier, and I get a lot of people coming up to me and sort of saying, so how should I do this? Or what's the right way to do this? And generally the answer is it depends. Right? What's your context? What are you trying to do? Why are you trying to do it that way? All those kinds of things. Does that kind of answer your question?
Thank you. How would you suggest in a diplomatic, graceful way? There are some people who kind of drag the process with their old school perceptions. Let's say they claim no requirements cannot be changed. You said, let's say, or you have to write those cases in details. No, you can't verify the database because QA doesn't have access to this, or you don't need to do this. I'm trying to kind of move step forward, and some people just dragging the process because they not used to agile process or be agile person.
Yeah, so it's a human condition, right? To not like change, to not want to change. So the question was really like, how do I deal with folks, and I think you're asking me how do I do it diplomatically, how do I deal with folks who basically don't want to change, that don't want to embrace Agile, that don't want to you know, change their way of thinking, their way of doing something. How do I answer that? Yeah. So I guess the best way I can answer that is like, try to show them the light. But Duncan wants to answer that.
If they don't want to change, I would have to have a very stern talk with them and probably let them go.
There is that, but the first step that I normally take is to try to basically make them see the light in that kind of very religious way, right? So you try to sell them on the value of what you're proposing. Try to get them to see how it can be better, or it can be different in a better way. So yeah, I mean, obviously, in any organisation, you will have folks that don't want to change.
Some people just get hostile and don't want to
listen. But if they're completely intransigent and they're not actually helping the team at all, and unfortunately that does generally mean that you have to sort of find a new opportunity for that person, even if that opportunity is outside your own company. Yeah, that's the diplomatic way of saying that. Any other questions? Yeah.
Stuart, just a quick comment and a question. You mentioned BED, and I'm glad you guys are doing it. And you said it's a popular approach. I'm sure it is, but it's not popular in Vancouver.
It's becoming popular.
Not yet, yeah, not yet. The second thing is, since you're doing TDD and BDD, have you thought of, or are you doing domain-driven design as well?
Yeah, I mean, I think the truth is that there's elements of all these things in just about what everyone's doing. It's labels, right? So, you know, BDD prescribes a certain way of doing things, TDD prescribes a certain way of doing things, and DDD does a similar sort of thing. But ultimately, there's another kind of, you know, popular topic amongst some of the thought leaders around context-driven testing. And you can just mash all of that stuff together and use that. Like, to me, BDD's, it's like a methodology that just describes getting people in a room and putting them in a situation where they've got to talk about whatever it is they're about to do. You're not really prescribing how they talk about it. You're not really saying, should you do that in a DDD way, or should you do that in even a TDD way, or a context-driven way, right? So, depending on who you've got in the room and how they think about things, you're going to get that. It's kind of like, I mentioned that I use sort of heuristics and you know, whiteboards and just talking to kind of get this stuff out, and that really breaks some of those barriers down. It's not like following a particular formula, it's basically saying what works for you and what works for the people in the room, and how do we get to the point we want to get to. And if people have a very sort of strong context-driven or domain-driven way, they're going to come at it from a certain angle, but you've got other people in the room who aren't going to come at it from the same angle, and when you get two different thought processes brought together, you generally get a better solution as a result of that. Actually, I mean, that really is kind of the point of the three amigos, right? Because you've got three people with different perspectives. The workshops that I've been running, I think at least some of the feedback I've got from folks is that it does open people's eyes in the sense that it's not just the PM or the customer representative who's going to always be the one or be the one to clarify requirements or tell you what it is we need to do. You as QAs or devs can have a voice and sort of say, well, shouldn't it work like this for the customer? Or shouldn't the customer see something like this when that happens? Like, we can affect those things. We can improve the design. And again, this is part of that sort of prevention thing. You can improve the design to avoid the bugs being made or the misunderstandings taking place or the assumptions being made. So I kind of think of BDD as a bit of a catch-all in the sense that it's just forcing those three different perspectives in the same room. You can apply those different approaches, if you like, in an overlaid way over the top of BDD, I think.
Question. Are you using the BDD approach for all the issues that your team work on, or just the larger ones?
Generally don't use it for issues. So we use BDD for features and stories, and where there's a hierarchy where a feature is typically, you know, something that a customer is going to get real value out of, and what we're actually trying to do then is break that down into stories, because the feature is generally too large to deliver in one chunk. So we kind of, you know, divide up that work into, okay, now I want to, you know, deliver a piece of this, say, a week at a time, for example. So you start with the feature, and some of the teams are experimenting, and kind of me and Duncan were talking about this earlier today, with the idea of having the whole team being a feature. And the reason for that is because for us, when we break that feature down into stories, those stories will probably be done in parallel, which means that different parts of the team will go off and work in different sort of implementation teams, as I call them, which is typically a dev, a QA, and a part-time sort of PM input, will go away and work on those individual stories. So having the whole team get the whole context of what the feature's meant to deliver really helps then facilitate the story level BDD of saying, okay, what's this kind of subset of that bigger thing that we're now talking about, and how do I define done for that?
It's blinking.
Yeah, basically. So we're hiring too, and sorry.
One more question about one of the previous slides, transition from trapezoid to pyramid. So in the very beginning you mentioned 3 different QA roles, and who is responsible?
2.
And developers.
Yes.
So developers are software engineers and tests, and QA engineers.
Yep.
Who is responsible for each of the parts, and for whom their share in test automation becomes higher or lower with this transition?
So I'll let you guess what I'm going to answer that with. No, I'm going to say it depends. So the question was, who's responsible for what? So there's 2 QA roles and a dev role, and who does which bits of automation in the pyramid? Well, there's a bit of a hint on this slide, but it does really depend. I kind of mentioned when I was talking about the SET role that, you can mix that up, right? So the SET can get involved in writing unit tests and like pair with the developer on that level. They can write integration tests, they can write UI tests. Or they could do none of that, and the developer could do it all. I mentioned earlier as well that when you're asking about the ratios between the teams, and again I said, if the team's really good at white box testing, in other words, the developers are really good at white box testing, they don't need that help from someone in a QA role. So what I'm really saying with that is I'm saying that you've got developers that think very critically and sort of write, they think of the right kind of tests, the types of tests we would think of, and they're applying those at a white box level. Then what they need help with is what happens when you build the system. A lot of this is really around, kind of think of white box testing as building it right, and black box testing is building the right thing. And it's the assurance of those things, right? So when you do black box testing, you're typically trying to say, is this the right thing? Is this the thing the customer wanted? Have I met the requirements adequately? Whereas with white box testing, you're saying, did I build it well? Did I build it robustly? Did I build it so it was scaled? Did I build it so that it would, resist attack? So yeah, it depends. And obviously, we have QAEs, so some of those traditional folks are getting more into the code. So they're getting to the level where they're sort of looking at the grey box stuff and sometimes looking at the actual tests themselves, the unit tests or the integration tests, and sort of commenting on them. Because essentially, even when you think about a unit of code and you're thinking of writing a test for that, it's basically a black box kind of methodology you're using to think about how to test that piece of code. So you can really genuinely add value at that stuff. It's just unlocking that kind of, either that fear, like you were mentioning about change, right? It's getting someone over that hump where they sort of think, I can't do that. I can't read code. Why? But if someone explains to them what the code's doing in a way that's internalizable, if you like, if that's a word, if they can actually sort of get the concept of what the code's trying to do, then they can actually add value in thinking of the tests and that. We good? No more.
How and when do you integrate security testing in your CI approach?
Good question. How and when do we integrate security testing in our CI approach? The completely brutally honest answer is we don't right now. So that's not entirely true actually. So we will automate tests. We will think of opportunities, vulnerabilities if you like, that we need to cover from a security point of view. What I think you're probably referring to though is, do we use any third-party tools to assess our security?
But also, where in the process do you run those tests?
Well, simple answer to that was the lowest layer we can. So if you're looking at, sort of how do you protect yourself against security at the code sort of level, at the validation level, you write code defensively, and obviously you'd write unit tests that assert that you have written code defensively, that you're not just blindly taking SQL and executing it, that you're not blindly taking JavaScript and executing that, for example. So when we think of them, we're adding them to our existing sort of layers in that sort of integration pipeline, in that CI pipeline. But in terms of the kind of more off-the-shelf or commercial type tools to do, say, pen testing or vulnerability testing or code analysis type stuff, we're actually looking at them right now. We're looking at ways in which we can integrate some of those things into our CI system. Right now, we do periodic scans of our code. We don't have it as part of the CI, so it's not run regularly. It's not run all the time.
So that's sort of what you see.
I'm not lying, am I, G? Just checking. Any more? Do you have a shortcut key, Ashman? So yeah, like I said, we're hiring. We're always interested in finding good critical thinkers or good test developers. And I have a blog and Twitter, usual. Okay, that's me.